All right, so hi everyone. We're super grateful to have OpenAI here presenting a workshop on how to use their API and an introduction onto how you can use it for their challenges. We have Andrew here presenting, and let's get started.
Hey everybody, my name is Andrew Main, and I work on creative applications at OpenAI with the API team, which means that I get to kind of play around with GPT-3, find cool things you can do with it, and then share them with everybody else. So I'm going to do a little bit of background on GPT-3 and kind of what it is, and I'll kind of go through this pretty quick. You are probably already familiar with language models, etc. But if you're not, or you have questions, feel free to pop things up into the chat. If I don't answer it in the middle of talking about things, we can come back to it later on. And if something comes up in the middle of me discussing this, don't be afraid. Go ahead and ask. It's meant to be a session where you learn how to use it, and I'm happy to sort of stop and explain stuff if it's helpful. So let me first start off by attempting to share my slide here. And let's go to my share screen, and I'm going to share with you let's go to the tab. I think this is the right one. Let's see if we get this right. There we go. Okay, perfect. So we're going to talk about working with GPT-3. And GPT-3 is what we call basically our language model. It is a third version of the GPT, which is called a generative pre-transformer. My name is Andrew Main, and as it says there, I work on creative applications at OpenAI. And the way to think about just about any form of artificial intelligence network is they're essentially prediction machines, and that's what GPT-3 does. You give it some text, and it tries to predict what is going to come next in a sequence. And I'll give you some more specific examples of that. And that's what you need to think about when you're building an application is it's text in, it's text out. The text that comes out is based upon what GPT-3 thinks should happen next. Now, the way that GPT-3 was made is kind of interesting. From those of you that may already know, is basically we took a huge amount of text, an immense amount of text from everything from reference material to conversational stuff to message boards, etc., put it in there so it could try to see patterns. So it could try to understand the difference between somebody answering questions to somebody writing an essay, which is why GPT-3 is so powerful, because it can do so many different things. And so we have a thing called a prompt. And what a prompt is the text that you send into it, and then the output is what comes out. And what we're going to be talking about will be prompt design, and that is how to try to get it to do the things you need it to do. Now, remember, GPT-3 is not performed to do any specific task. You're going to see it do things like perform as a chatbot, act as a classifier, and other functions, but there was no programming behind the scenes to say specifically this is how you should do this task. These are things it learned by itself by looking at text. And that's one of the exciting things about working with GPT-3 is you might discover something that nobody else realized it could do before. You might find that it has some new capability of text, that it can generate something you haven't seen. I play with this, and I'm going to show you a bunch of the prompts that we have in our example library. Some of these are ones I came up with because I was just like, I wonder what it can do. What if we try this? What if we try that? And sometimes it can't do it. I couldn't figure out how to get it to do what I wanted to do. Sometimes we can. And so we've built up a really cool collection of capabilities that were just done by people exploring. We're going to have some settings here. I'm not going to go too deep into them, but just to explain roughly the ones that are kind of critical, you're going to hear something called temperature. And remember when I said it's a prediction machine, which means it tries to predict what comes next. But when it's predicting, it can have a range for what it thinks should be the next text that appears. And I'll show you an example in the playground more specifically of this, but think of it as adjusting the randomness. It can consider a wider number of possibilities. If you're building something like a classifier, like trying to tell you what category an industry belongs to, you would set your temperature low. Or if you're trying to predict sentiment, you would keep it low. But if you were doing something creative like storytelling and you wanted GPT-3 to kind of go anywhere, even in a wild abstract sort of way, you would set the temperature very high. So think of temperature as sort of affecting the randomness, the number of possibilities it will consider. And you can play with it and you'll see very quickly, if you set it very low, it'll give you the same answer over and over again. Set it high, it'll give you a lot of different answers. But when there's one right answer or just a few, you tend to want to go lower. And sometimes this trips people up, but if you think about it that way, it can be helpful. So that's, again, low, medium, and high. And one of the things that I sort of do when I want to create a prompt is I try to think about how GPT-3 would have learned in the world around us, how it would have learned from text how to do a thing. And that can be helpful. For example, you can find little magic keywords. For instance, if you use the word tag at the end of an article, it knows what a tag is from looking at blog posts, and it'll just create tags automatically. I don't have to create a very complicated prompt to tell it, give me the keywords. I can just use the word tags, and it'll do that. And a lot of little other ones that you can find like that. But just think about how it would encounter text, and that would give you kind of an idea of how to get it to create a prompt. A way to think about sometimes too is if you get the wrong answer, GPT-3, if it's within the realm of capability, meaning it's something it can know or something that's understood, it doesn't mean that it got it wrong so much as you need to phrase the question differently. And that's not to mean to say, oh, it should do everything. It shouldn't. But often you can learn a lot by looking at the answers and say, okay, why did it think I wanted this? If it keeps doing that, how am I phrasing it? What am I telling it? Does this mean something different to it than it means to me? So some of the best things I've learned from GPT-3 is by giving it a task and seeing how it consistently does something maybe differently than I expect, and then backtracking and figuring out, oh, I can use this as a different kind of prompt. Okay. So again, prompt writing is the way we give instructions, and there's going to be two ways I'll show you. One is sort of just the normal way that we've been doing at GPT-3, where you create a prompt and it tries to complete it. And then we have a series of variations of the models called instruct, which has been trained a little bit to follow instructions, which makes it easier to perform a lot of tasks. But you can do just about anything with instruct. You can do the normal model. Instruct just generally makes it, where you need fewer words to do that. So what is the perfect prompt? I don't know. I'm always surprised by what people come up with. There seem to be better ways to get things done, and I'm always trying to figure out ways to make things more efficient. And there's ways to make complex prompts where you take the idea that it knows how to do a thing here, and then you restructure the way you want it to do it, and you can get it to perform complex things. An example would be I could train it on how to be a sentiment classifier with just a few examples, and then I could show it a big list of like 20 things, like 20 tweets or 20 social media messages, and then say what was the sentiment there, and it'll perform it for all 20. It learns it here, but then we'll do the task differently down there. And that's something I found just by playing around with it. Okay, so the answer to the perfect prompt, I don't know. Okay, so prompt design is ongoing. You have to play around with it. We're always finding new ways to do stuff. You can learn from unexpected results. And we'll start with here just the documentation, which I'm going to show you. And let's begin basically with that, and then we're going to go into the playground, and we'll see some different ways to make this all work. So let me go over and switch screens here to a different one, and we'll take a look there. I don't know, do you all have access yet to the playground? We'll find that out in a second. So let's go over to a different screen here. Okay, cool. So as I explain this, you guys can go take a look and you can check things out. So let me go over to here and let's go share. Let's just start in the playground right now. Okay. So this is our playground, and we can take a look here, and you can see you've got a few different settings. This stuff over on the right here can be a little bit confusing at first. Response length is just how long you want it to respond. And GPT-3 works in tokens, and tokens are roughly approximately words. They're really the way the model breaks things down. And to think about the internal way the model works, it takes all of this information we've given it, and it tries to kind of compress it down. And it compresses it down by creating something called kind of embeddings. And these are, in a way, it has its own sort of neurons. And things can be closer to each other that are related to each other. If you have the word, let's say, space and astronaut, it might have those things kind of put together because they appear a lot. And that's why it might know contextually if somebody's talking about astronauts, well, they're talking about space. So if you imagine a kind of if you think of a word cloud, but even more of wordish like clouds, because you might realize these two words are pretty similar together, so they're going to be very adjacent. And that's how you're able to get it to do things. It says, okay, this is connected to this. This is related to this. I know how to structure a sentence, and I'm going to work my way through there. Now, let's do just a simple example here. I'm going to set things low. So what response length is, I'm going to limit the number of tokens to just 64. Temperature, I'm going to set temperature all the way down to 0. Top P is another way to affect the randomness. And this uses something called nucleus sampling, which we don't need to get into here, but it's another way to do that. Frequency penalty affects how frequently tokens come up again, how often it repeats words. And presence penalty is sort of like penalizing by things by being overrepresented. Best of allows you, if you want to if you have a prompt that has some variation on it, you can use best of to say, come back with the best response out of 3. Now, the way that it evaluates and figure out what is the best of is it uses a thing called log probabilities, which is basically trying to look at the total value of saying this has a higher value than a lower value by looking at the token values. It can be very useful, but don't get too tripped up on it if it has a different idea of what is best than yours. It doesn't really know what you mean by best. And stop sequence is a way to tell it when to stop. Like if you put in a period, it will stop when it gets to a period. So I'm just going to put a period in there and press the tab button. So whenever it gets to a period, it will say stop. So an example right now, if I write hello and I click submit, and it says, hello, I'm a newbie to this forum and I'm looking for some advice. Now, right there, that's a little clue to some of the ways in which GPT-3 was trained. This is something that probably came from a forum. And so it probably read a lot of different forums and conversations between people. And this is evident because we set the temperature really low. And the first thing it wants to say after it hears hello is like, well, maybe somebody's introducing themselves on a forum, which is a very common thing for somebody to say. So let's go ahead and try something different. Let's try another example. And again, this is when we have the temperature set really, really low. I'm going to give it a simple, let's type in there a long time ago. Okay. A long time ago in a galaxy far, far away. And it starts writing basically part of the opening crawl of Star Wars. It's decided that whenever it sees a long time ago, most times it sees that probably relates to Star Wars. And that's because we have the temperature set really low. Now, if I set that temperature much higher and I go back and I let it try that again, it writes something completely different. A long time ago in a faraway galaxy in the constellation of Andromeda, a giant blue star exploded in a grand cosmic fireworks show. So that's showing you what temperature can do. Now, if I click submit, if I redo this and I can click submit again, it does a galaxy far away. The set was called the Millennium Falcon set. I can use this, which is a regenerate, which basically just starts all over again. And you notice we're getting a different response every time when we have the temperature set high. Now, you notice this will pop up from time to time. We have a filter in there that's trying to be aware of when something comes up that might be slightly sensitive content, and it is going to be overreactive, and that's by design, as we want to just, kind of not take a chance. And so basically we're going to say, hey, this may be sensitive. So if you're building an application where this comes up, you'd probably want to add some middle layer. But that's what this means when you see that. And if you see it and it comes up and it behaves the way it's supposed to or the way it's not supposed to, you can go ahead and click on here and you can report it and let us know. And this helps us improve these filters over time. Let's go set the temperature really low, back to 0, and let's do regenerate again. And you see we got the same exact thing we had before. It's decided that it's going to keep saying that, and that's because it's only considering one narrow realm of possibility. So that's just to sort of show you how the completion works, but let's go ahead and try another example of something. I'm going to get rid of the period here, and let's say I wrote a list of my favorite movies about space. Okay, if I write that, and let's set the temperature, we'll put it like, I don't know, about around 3. It decided, okay, maybe this is a list of this, but if I go back and regenerate this, it has a pretty good idea of how to like fold out with a list. But if I want to make sure that it's specifically going to give me a list, I can just go and write number 1, which is sort of priming it. If I do that, it automatically starts making a list, okay? If I just wrote my favorite movies about space and did this time we get a list, but it's very repetitive there. So we could try this again, and it starts to write a little bit of an essay, and it starts to be a little redundant there. So if I go back and then I add that number 1, it should definitely give me a list. And there you go. So that's a way to think about things. If I wanted a list, the best way to get that was to not only say, hey, this is a list, but to start off with the number 1, because that in the world of text is pretty indicative that you want a list. you might say some of my favorite movies are, and you say a list of my favorite movies might include this or whatever, etc. Okay. Question comes in here. Aditya wants to, is that where the frequency penalty would be useful to penalize repetition? Absolutely. So if you have it, when you set it pretty low, if we set this pretty low like here, and I go back and we regenerate, we might see, we're seeing The Martian come up again and again, which, yeah, it's a great movie, but I don't know if we need to put it in that many times. So if I bring, and the reason it's coming up that many is because that the probability is low, so it's considering a smaller range of probabilities. So the way to adjust that would really be increased temperature, but I can take the frequency penalty and say like, hey, don't repeat yourself as much. And you'll notice that it didn't repeat itself as much, but it also stopped there because it's like, I think I'm running out of examples, okay? But if we go in there and we increase the temperature, which says, hey, consider a wider range. When you hear movies about space, consider anything that remotely relates. And well, it starts off there, but it's giving us more stuff here. And that if we keep doing like that, and I can keep doing, we're getting a longer list. So if I go set the temperature higher, and also let me just turn the response length a bit larger. We can just keep submitting it, and you'll find that you'll get better results as you do that. And we can bring the frequency penalty down at that point too if we're using a higher randomness. But that's exactly what that does. And you'll find that can be pretty useful there. There, we're just getting a list of numbers. And you're going to see that sometimes you need to prime things to keep it from being repetitive like that. But you'll be able to find the right setting for your application if you just play around. And sometimes it can be a little daunting because you're like, oh, I'm getting this. It's erratic. Well, remember, it's designed to do a lot of different things, which means that you have to be specific about what you want it to do. Because if it just sees a list like this, it might decide, oh, I'm only making a list of numbers. But you could actually prevent that by priming it with this. Notice this is what happens when we don't put a stop sequence that's pretty low there, is we count all the way up to 100. So let's go back down to our response length. Let's set our temperature much higher, and let's try to regenerate. And we get a list formatted like that. Okay, so that's just one way you could use it to create something like a list, and you'll find there's easier ways to format it and do that. Okay. So what is the purpose of the response length? So the purpose of response length is you saw how it went all the way and it kept numbering things. That was because I said, just keep answering until you reach this many tokens. So what happened is it said, oh, I've got like 300 tokens. Like I can add 300 words to it. Sometimes you just want a small one. In tokens use computing power, which costs money. So you want to try to limit it to as few as you need, or use a limiter like a stop sequence. So that's the purpose of the response length. If you just want a one-word answer, just give it a few tokens. If you want something longer, then you would set it higher. Probably, and I'll show you one other example too. Like you can kind of, the model has some really neat, already has some information that's already inside of there, which is great. Now, most of that information is like frozen to like, a few months ago. So it's not going to have current events, but it's going to have a lot of information about the world around it and information about books and stuff. So you can talk about, like, if you were to write an essay or something, you needed topic points, you could just put in here like, oh, like I want to know major, discoveries in astronomy. Okay. And we get Herschel's discoveries. We've got a bunch of other lists there. So that's one of the cool ways you can use it, is you can just throw something at it. Like, tell me the most important things in paleontology. Tell me who are the top writers in the 19th century writing, naval fiction, et cetera. And it will do that. It will have a pretty good understanding of how to answer this. So there's a lot of knowledge in there. For certain tasks, you want to make sure that you have ways to check it. And there are ways to sort of use outside knowledge and then have GPT-3 reformat it, which comes to like my favorite prompt of all is the summarization prompt. And I'm going to load this here, and let me pull this up. We have one called Summarize for a second grader, but I'm going to get rid of this and just paste in my own. And what this does is GPT-3 not only just generates text, it can read the text that came before it and then interpret it and understand it. And not just, you may have seen applications in language models that can do summarization. GPT-3 summarization is like another level. It can take text, it can summarize it, it can actually rewrite it for an audience. So if I give it the passage on Jupiter from Wikipedia, the first 3 paragraphs, and I tell it to explain it to a second grader, it's going to do a couple things. It's going to read through that text. It's going to try to synthesize that information, and then it's going to try to format that for a younger audience, which is, a concept in psychology is theory of mind, which is the understanding of how, or a model for how other people think. Okay. So let's go ahead and see what happens here. And so this is the text you would add. You could just copy paste whatever you wanted in there, but I'm just going to put this in there, which is about Jupiter. And let's click submit, and let's see how it handles this. Now you see it says the planet Jupiter is the 5th planet of the sun. It is very big. It is named after the Roman god Jupiter. It is very bright, has many moons. Juno is going to visit Jupiter soon. We just talked about the space probe. Now you notice it repeats itself there, so we could set the frequency penalty a bit higher and regenerate that, and we get a much better response. All we had to do is adjust the frequency penalty and say, like, don't repeat yourself. You're doing great. And it does that. And we get a very good description about Jupiter. So question we had there is, Richard asks, approximately how large is stored, how large is stored the knowledge base of GPT-3? What I can tell you is that it has 175 billion parameters. Okay, that's 175 billion. Basically, think of them almost like neurons. To create GPT-3, we took an immense amount of information and built the 5th largest supercomputer in the world, to then take this knowledge and basically compress it into the language model that we have here. So as far as the total size of all the data in there, that I don't know, but I know there's 175 billion parameters in there, which means that it's a very, very complex model. But it has, you'll find things in Wikipedia, you'll find things in textbooks, etc. There's just so much stuff out there. Okay. And Aditya writes, this model is remarkable at understanding the structure of input. I was pointing out the other day and fed it a LinkedIn post, and it was able to generate LinkedIn posts based on very minimal other information. True. Absolutely true. That's the thing that's really cool about it, is that once you understand that it's learned from these examples like that, it can be easier to create prompts. Sometimes people will say, like, okay, tell me about blank. Well, maybe you just need to say, write a blog post about blank, or write a Wikipedia article about blank. And it will go, oh, I understand the size, and I understand the audience, and I understand the structure of these things. And so I can do this much better than that. And Aditya, you stumbled upon something there, or intentionally found something there, which is one of these little shortcuts is say, oh, wait, does it understand what LinkedIn is? Oh, cool. Then I can just have it generate something like a LinkedIn post without having to have a bunch of examples, because it already knows. One of the mistakes people make in prompt design is sometimes they use too many examples, because we're used to, training models and giving them a lot of data, and GPT-3 is essentially pre-trained. So it already knows how to do stuff. Sometimes you have to give it examples, but I would say 9 times out of 10, people come to me with like, oh, I want to be able to do this, or I'm trying to make it do this. And I'm like, it already knows how to do that. You just got to ask it the right way, and it can perform that task. As far as the actual size of the stored knowledge base, that I don't know how much actual data is inside of there, but it's very large. It's very large. There's a lot in there. It's surprising to see what comes up in there. Let's move on to the next example. So you saw right there, though, with how it was able to summarize that. And you could use that for a lot of different things. One of the cooler applications I've seen, there have been a couple companies, some startups that are basically using this to look at machine information or data that comes out of like logs about like, when you have an application, you have a problem, using GPT-3 to explain what's going on, to look at code, to say what's taking place here. Another cool thing I saw was somebody used that you could use it to summarize and also to create content. Somebody built a thing that was able to create AWS bucket policies. And if you ever have to work with that and to try to generate those, it can be very frustrating. But the ability for it to understand how to convert one kind of text into another text is super powerful. And it's easy to get fixated on, its ability to be a chat bot or its ability to answer questions, and to forget that the idea that it can take one kind of information and turn it into another kind is incredibly powerful. That's what underlies, translation. That's what underlies so many other important applications out there. Using large amounts of data and trying to find things out. You can give it a large article and you could ask it a question about, did this happen? Did this take place? Whatever. And then you could build a system that could read through hundreds of articles and then summarize all of them and give you key details. that would be powerful, or that text could be, you know, customer support, all sorts of other things. So when you start thinking about GPT-3, one of the things to approach it is just think about, like, what is a problem out there that relates to text, and could it solve it? And text can come in any forms. Code is text, conversation is text, etc. So I'm going to show you another little quick sort of way, though. So we have this task here where we used, let me get rid of the that, and let me go back in. I'm going to put the text here from Wikipedia, which was the article. And then instead of writing a prompt going all the way around it, I'm just going to put TLDR down there. And usually this works. So let's see what happens. Notice what it did there is you saw, this is great. This shows you it has edit, whatever. So it kind of starts to behave like maybe it thinks it's a Wikipedia article. But let's set the temperature kind of low here. And then I'm going to put a stop sequence of a period. And let's see if it will just give us a TLDR. You know, too long, didn't read. And there we go. Jupiter is the largest planet in the solar system, and it's the 5th planet from the sun. It was able to understand that a TLDR is taking all this and summarize it into one concise statement. We did not have to write an elaborate prompt. There are 6 characters. It only took us 6 characters to get it to summarize all of that into a sentence. And you're going to find other little magic words like this and phrases if you try it. Okay. Let's take a look here at the, let's go to the next one. Oh, let me check this out. Harsha says, I had a friend do something pretty interesting yesterday with Playground. He drew an incomplete smiley face, was missing an eye, using graphics tool, turned it into an SVG and pasted it into there. It generated the necessary SVG code to add an extra eye to the smiley face. That's great. And so, and SVG, as you know, is a way to turn graphics into sort of a textual sort of format, not just like a binary like you would a JPEG or some other image form. And you'll find little surprising things. I was surprised when I first got it to use emoji. But then emoji are actually have basically text descriptions behind it. You know, it'll say smiling face or whatever. But GPT-3 will understand that. If it's seen, you know, if it's seen SVG and stuff out there like that, it's capable of doing that. GPT-3 also answers questions, right? Like a Q&A system. Absolutely. We'll get to that in a second. It can answer questions. It can have conversations. It can pretend it's other people and it answers questions. It is incredibly capable. Let me show you a example of how much it understands different forms of text. One of the ways that we have text is text can be in the form of a spreadsheet. And so if I say a spreadsheet of the top movies in the year of release, let's put the top movies and I don't we need that top movies in year of release. And if we get rid of my period and let's go ahead and click this, and it's adding all these other details there, which we don't need to do. So let's go ahead and set this temperature lower, and let's try this with the new, see if it does it with the new line. And there we go. It starts creating a list of movies and the year of release. In that format, if I took this and I put this, if I saved this text right here into a text document right now, and I imported it as a CSV, but I imported it with pipe separated, if I just said that was my separator, it would open up in a spreadsheet document. We've created a spreadsheet here through text by just showing it the format that we wanted to respond. And you can make these things a little more complex. And I didn't even give it any starting. I didn't even prime it with anything to tell it how to do it. I can do this with, you know, sometimes you might have to give it a more specific example, like show the first row of what it should look like. But let's try it with this, the science fiction movies, directors, and year of release. And there you go. We're getting this generating text again. So just to show you its versatility. So we had a question about, can it answer questions? And the answer is very, very simple. I can just ask, I can put Q, what year did we land on the moon? And I can put answer, and I'm going to put in a stop sequence of a return so it doesn't keep going. If I just ask it like that, 1969, it knows right away. It sees question, it sees answer, and it's able to answer questions without having to do anything else. I could probably just write, what year did we land on the moon? And, oh wait, go there. And there it's actually wanting to return, so it's stopping after that. And it gives us a more fuller example. But if I just put it into that format of Q and then A, it understands clearly the Q means question and what A means, and it's able to do that. Now, if I don't put a stop sequence in here, this is the fun part, because it's a language model, it's not specifically Q&A model, means that it might assume, okay, maybe I'm trying to replicate an entire Q&A session. So if I just let it run like that, it's going to answer that question, and then it's going to ask its own questions, which I think is kind of awesome. So we can use this, though, in a more interesting format. So if I want to create a chatbot, right? And so let's do a chatbot that answers questions about music. One of the problems in working with language models is they're capable of going any direction. It can answer you a yes or no question. It can also write an essay, and it also could take a point of view of somebody. And so when it's looking at the world of text, it doesn't necessarily know what it's doing or what's appropriate too. It could write, a violent sword and sorcery epic, or it could be a very normal classifier telling you, what color goes with what number value. So because of that, you have to be, in a position as a developer to create kind of guardrails to say, no, do this, don't do this other thing. And when you create applications where people can talk to GPT-3, you want to prevent them from taking it off task and trying to use it for something else, particularly if it's consumer facing. So if we have a music bot that answers questions about music, we want to make sure that it answers questions about music and somebody doesn't use this to start playing a role-playing game where they're like killing dragons or something. Well, that would be awesome. So one of the techniques you can do this is I came up with a thing called, kind of the middle layer, which is basically the user would ask a question. Then I'd have GPT-3 ask itself, is this a music question, where it has to consider this text before it and then come up with an answer. And then say music bot will answer it if it's a music question. Now, I use these separators here to separate each one of these. You can use different separators. This doesn't really have too much of a specific, meaning to GPT-3 other than in the world of journalism, that's used as a separator, or for copy text just to separate things, but you could use other separators. So if I say, user was Frank Sinatra an astronaut, I tell it, is this a music question? No, because the answer doesn't relate to music. The question does, but not necessarily the answer. So it says, I can only answer questions about music. So the goal of this is to keep our music bot on task and to prevent it from helping somebody figure out how to rob a bank, which you wouldn't want it to do. And it wouldn't really be that good at it. Anyhow, I'd probably pull something from a comic book. So we have this format of user, then asking GPT-3, is this a music question? Yes or no, and then answering the question. So I'm going to put in a stop sequence here of the 3 hashtags, like so, pound symbols, and who composed the music for Avatar? And I have a temperature set pretty low, so that should be fine. And it didn't bother answering the question there, but it didn't bother giving me, is this a music question? But it went ahead and said James Horner is the composer for that. Now, if we set the temperature a little bit higher, and let's go back, it goes in and it answers that. So what we're able to do here is basically, if I go start from there, and I let it basically fill out the whole thing by itself, it fills that in. So it understands who composed the music for Avatar. Is this a music question? Yes. What? What is the square? Well, that's a new way to spell square root of 5. Okay. Let's ask it that question, see what happens. Apparently decided that, well, that's because I have the temperature set really high. It's glad that it's be helpful. Of course, music is connected to numbers. So, okay, it says this is a music question. No, but it decided to answer it anyways. So you probably want to adjust your settings there, but you can see it has the ability to figure out, like, should I answer this or should I not? So if I gave it a few more examples, because I only have one here of say don't answer it if it's not a music question, you'll give it a couple more and it'll know, don't actually answer that question. But here you can see it has that ability to say no. So if I was building an app, I would just say, look, did it say yes or no? If it said no, don't answer the, no, don't finish the rest of this, or don't show the user the rest of this. That's all I need to do. As you see, it wants to answer that question. But if I just say, well, is it music related? No. Okay. Don't care what you say next, because I'm not going to use this answer. So that's one of the ways you can sort of build kind of a system to prevent it from going off the rails when you don't want it to. So just consider that a middle layer. Okay. One of the things it can do is it can translate. So I can just remember how we did Q&A, and if I just put if I say English, I do not speak French. And then I put, I just write the word French. Let's just see if this works like this. I might have to prime it with something else, but I think we should be fine there. No, that's correct. So right there, it's able to translate without any examples. Now, you might need to have more nuanced translations because different languages have different ways of using tenses. They have formal and informal versions. So you might provide more examples of this. And so if you're trying to use a language that's a little more structured, you might say, no, I'm looking for this way of responding to it. But you can build a translator very easily just by saying English and the other language. And it's got a lot of other languages. It's not a complete list of languages, to be sure, but a lot of European languages, some Asiatic languages, Romance languages, etc. So you'll find a number of them in there. So you can play around with it. I've had it do like Vietnamese, just limited amounts of it. So that can be pretty cool. Of course, when you start getting it responding to that and not speaking Vietnamese like myself, I get confused. But you can see that can do a lot of things like languages. Okay, let's show you. I'm going to show you something kind of cool, which you saw the summarizer, right? Now, sometimes you have tasks where you get a lot of information, like people fill out surveys, people fill out data. And if you get hundreds of people responding to something, that can be problematic. I have friends that do Kickstarter campaigns and they put out these surveys and then they get hundreds and hundreds of responses back. And it's hard to go through and to process that. So you could do something where instead of trying to process that, by yourself, you could use GPT-3 to basically take that information, this would be the customer response, and then put it into basically give you answers that fit categories that could then go into a spreadsheet. So I could find out how many people like this, how many people didn't like it, et cetera, without having to process all that by yourself. So here we created a prompt that says, read this customer response, then answer the following questions. And this is somebody commenting about a game called World War Mice, saying what they liked, what they didn't like. And then we have questions. What product was this about? Did the customer have complaints? What was their main comment? If they were unsatisfied, what can we do to fix the problem? Was the customer polite? Which can often be a useful thing to figure out how much time you want to spend answering that question. So we'll put the temperature at about 0.3 there. And I'll get rid of that stop sequence. And let's increase the response length a bit here. And that could be our little stop sequence in case I want to keep it from going. So I'm just going to put that in there like that. So let's go ahead and see if this will answer it. It knew what the product was about. This was about World War Mice. Yes, the customer had complaints. The main comment was the game wasn't exciting as the trailer. We can fix it by making the game more exciting. Yes, the customer was polite. Now notice it started creating new content here. Now it has two returns. So if I just type that in there, if we do this again, it should stop right after that. So let's go back and answer this again. So let's go set that too, because I don't know if it mentioned the game trailer. So if we bring that temperature down a little lower, let's see what response we get. Yeah, and that's pretty consistent. So just by doing that, we now have a way that we can get responses out, and we can just take that data, parse it, and put it into a spreadsheet, and would be able to basically use this in a more meaningful format. You could process hundreds of customer feedback responses in minutes and put that into a spreadsheet and quickly know what people thought instead of having to spend a lot of hours. And that's a whole area of possible, applications for it, because so much of what we're trying to do now in basically the world of communications with customers, internally, et cetera, is take a ton of data and then figure it out. Could GPT-3 do my math homework? Some of your math homework, yes. It's a language model, though, so you have to figure out how to work into the parameters of that. And you're probably better off with Wolfram Alpha than, for some of the harder things. But it can do some things, and that can be surprising. So how can we train it on unique information, say an FAQ chatbot for a particular business? Okay, this is a great question. There's a couple ways you can do this. It really depends upon the amount of information you have to do. If you can fit everything you need about that business into a prompt, which a prompt is limited by 2,048 tokens, which is roughly like, say, 1,600 words or so. If all of that can fit inside of there, if you have a description of the company, everything, you put it inside of there, then you could basically use that like we did before with the summarizer, and we can just ask a question. Like if I go back and I take this text about Jupiter, okay, and then I say, If I ask question, what is Jupiter? I'm normally a better typer, I promise you. Made of. All right, and we put answer, and then I'm going to go ahead and put just a single return to stop it. What is Jupiter made of? The answer should be hydrogen. Yep, hydrogen and helium. So there we go. It was able to take the text from here, okay, and it was able to summarize this. So it knew hydrogen and helium because it understood this from there. So you could have a company, company information right there. You could also use a thing, which I'm going to demo in a second, called semantic search, which is to find the relevant document and have it summarized from that. You could also give it basically you could give it a list of Q&As before, and it will pull up the one that's the most similar and say, oh yeah, this was answered here before. So that's one of the ways in which you can do it. So question here is, if you had 100 different game reviews, how would you go about getting the question answers for every one? There is basically, if you had, well, you're asking like what, I mean, when you say getting question answers, or like if you have a list of 100 questions or what, I'll show you a prompt that might kind of show you kind of a way to think about that in a second. But let's actually, let me go in here and I'm going to show you, some of the documentation, and I'll show you the prompt that relates to that. And then I want to show you semantic search, which might be another thing which you could apply to that. So let me just stop sharing here, and then we will pop over to here. So again, hello, it's me. So let's go share. What screen do I have? If you go into our the test site here, or if you go into the back of the beta site here, you'll see different things, including the playground, some resources in which you can use different things to do this. You'll see a thing called interactive tools, which actually takes to a page called GPT tools, which is something I made, which we use in a second to do semantic search. But if we go to examples, you can see we have a bunch of different examples here. And one of them is, I have a thing here called the advanced tweet classifier, which we show it right here, how to basically classify a tweet, and then basically how to format into a response like this, and then sentiment. And then basically we say, okay, let's just give it a list of these things. You can actually make that list really long. So you can show it, these are tweets. This is the text. This is the response I want. Now that you know how to do this, like just go ahead and do this with a longer list. So you can show it how to start with a small list and how to do it, and give it a more like a Q, and you can have like a customer conversation back and forth. Then you can just start asking it straight up questions, and it knows, okay, I get what we're doing now. This is the topic we're on. This is the theme. So might be a little helpful, but let me show you semantic search, which let me switch over to that. Semantic search is another way you can use the API. And what it is it takes an input, which is, we call it a document, okay, or a query, and then a list of documents. Now, when I first heard about this tripped me up because I thought the list of documents literally had to be like a bunch of text files or something. All that means is you give it some text here and then a list of other text, like an array of text objects, and it will find the ones that most closely match the query. It'll rank each one basically to how closely it matches the query. And you're using GPT-3 to say, I've got this. What fits this the best? Now, the cool thing, because GPT-3 has a really neat understanding of language, it doesn't just mean that it's looking for keywords. It can do it with other things. So if I say, if I use it to do a sentiment analysis, and I say, this is my query, and these are my documents, which is just going to be this text separated by this, which in the app, in the browser here, I'm just going to split this into an array. And it could be positive, negative, or neutral. And then if I click analyze, it comes back and says, oh, this tweet is positive. There's nothing else going on there. There's no prompt. There is on the API side, the way semantic search works, it's basically saying which one fits the best. But from your end as a developer, all I'm sending is this text here and these 3 items and saying score each one of these. And it doesn't compare them to each other. It just compares each one to there and gives you a number. And then in the browser, I'm just saying, okay, this is the highest value, so I'll put it up there. This tweet is positive. And so that's a very powerful tool. Now, tweet sentiment sentiment in general is a pretty simple sort of task. It's the hello world of language models right now, but you could use it for industry category. I could say Uber, which one does Uber best fit? And I could say just limit it to these categories and we get transportation. If I put in FedEx, I get logistics, which, it'd be more shipping. So I could just add a new document, which is shipping. And it will say, yeah, shipping fits best out of all of these. So you can do it with something really cool. Let's take the 7 basic plots. So we have the quest, we have tragedy, we have rebirth, voyage and return. And I'm just going to put the word Jaws in there. Because GPT-3 is smart enough to know when it sees the word Jaws, it might mean the movie or the book. I don't have to explain anything. I don't have to put the plot in there. I can just say, Jaws, what plot does it fit the most? And it says overcoming the monster, which I would say that's pretty accurate. And this has a 189 score, and the next closest one is 67, Voyage and Return, which still kind of fits. And Quest, all 3 of these positive rankings are pretty good ones. The negative ones are, not as likely. So that shows you how powerful it is. It's able to look at that and compare it. So let's use The Hobbit. Okay, it helps that both of these are books and movies, so it has a pretty good understanding of that. The Quest, it comes back with it being the Quest, which is pretty good. You look through the different other themes there. It actually puts rags to riches in there, which in The Hobbit, as you know, there's gold and stuff. And it says like, yeah, maybe that fits. And the ones that says it doesn't fit, tragedy or comedy, seem to be pretty accurate. Now, if I wanted it to analyze a story of my own, and it's not something it's familiar with, I would then put in a description of the plot. This happens and this happens, this happens, and it will then figure out what fits best. So that's a really cool application that you couldn't get that from just keyword matching. You couldn't get that from just a simple model. It has to understand, what does tragedy really mean? What is a quest? What do these things relate to when it comes to genres like fiction and literature? You can use another tactic you can use too is you can do text content, but let's use directors and movies. Okay. So if I ask it for the director of Wayne's World, it knows it's Penelope Spheris. But if I put in the director of Casino, it doesn't have an answer because it can only provide me an answer from this list here, right? But if I want to have the option for sometimes it to not know because it's not on the list, I can use something I call a generic type, which is called, I'll say, the director. And if I put in the director, it says, oh, well, the director is the best, is the highest ranking one here, then all the other people. But if I put in the director of Avatar, it says James Cameron. And notice how the director then added, it sort of functions as a split. It separates the correct answer from the incorrect answers. So that's kind of a cool way to use it. So if I put director of science fiction, let's see what happens there. We get Ridley Scott, James Cameron, Spielberg, Nolan, and then deciding that George Lucas isn't a science fiction director, which there's some people make that argument. But you can see you can use that as a separator to separate things from there. The people at the lower end aren't necessarily known for having done science fiction. So that's one of the ways you could use semantic search. Again, you'll see this in the documentation. It's very straightforward. Is you take your query and then you take some text and send it in text documents like in an array and say, okay, give me a score for each one, and then I'll figure out how it fits. So question is, Samir says, if what you did with that one game review, if you want to do that, but for 100 game reviews. So you could try to use that like advanced form I showed you before. Remember, you've got that token limit. So you've got 2,000 tokens that are limiting you. But you could basically just take that and send it to the easiest way is to send it to the API 100 times. To send it to the API over and over again and say, categorize this, categorize this, categorize this. You could show it, hey, this is how to break this into, let me switch off my screen here. You could say, hey, this is like I did before that prompt where I showed you how to get the data. You can say, here's the data here. And then you could say like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and list each one of those is one of those reviews. And then give it another list and say, now give me the answer starting with number 1 and do the same thing. So go look at that tweet classifier example, I guess, to kind of get a better example. So we still got a little time left here. So any more questions? Perfect. It's really the best way is sort of to play around with things and to try stuff, experiment with it, try different prompts. I think, maybe you guys already have examples of what you want to do with it. Maybe you don't. Play around with it, and maybe you can squeeze it sometimes into a use case, but sometimes if you say, hey, broadly, what do I want to do here? And you could say, okay, I could use this to analyze game reviews, but you might say, okay, what do I really want to do with a game review? I want to get data back from people. And if you are at the point where maybe you have a game and you want to make it easy for people to create that information for you, you might find ways to use GPT-3 to make it easier for somebody to write a review. You might decide, is there a way to summarize this in some other format? Start thinking more broadly about the possibilities of it, and you'll come up with, really, really cool applications. And I think one of the things to do is like take it and then go in slightly different direction. This is a great question, which I didn't even cover. Travis wants to know, can you talk more about the different engines? So the engines are basically different capabilities, like different sized models that we use. DaVinci is the most powerful. DaVinci is the biggest and the most powerful one. And then Ada is the smallest one. Ada is the fastest one, though. Now, Ada doesn't have as much information and isn't as capable as DaVinci, but Ada is much cheaper to use and much faster. You have Ada, Babbage, Curie, and then DaVinci, and then a couple variations of them, which I'll explain in a second. So DaVinci is kind of the smartest one. I start with DaVinci, see what DaVinci can do, and then I try to step down to a smaller model, because if you can go from DaVinci to Curie, Curie costs 1/10 the cost of DaVinci. And then Babbage is like, 1/50th or something. So the models are basically different versions of GPT-3, different sizes. You can think of it like one's more powerful than the other, but the smaller ones are faster, which can be very useful and can be useful for a lot of different things. We also have like DaVinci Instruct, Curie Instruct. What these are versions of the models that are trained to basically know how to answer something more specifically. So let me go back. I'm going to share my screen again with you just to show that in the playground. So let me just pull up. Over here, I set it to DaVinci Instruct, okay? So what DaVinci Instruct is basically, we took a bunch of examples of prompts that people were making, and then we said, okay, can we just make it where we just tell it what we do? Make a, make a list of comic books. I'm just going to type that there, and let me set the temperature a little bit higher, okay? Oh, I have a character turn. And if I used regular DaVinci with that, it might not have understood that I wanted a list of this. So you can just say, tell it, make a list of this. You can say, write an essay about Mars colonization. Okay. And it understood that's what we wanted. So this is basically DaVinci that's been trained to understand how to sort of follow instructions. That's what we call it instruct. So those are different models. And let me show you kind of a good example of if we use, so we have Curie Instruct, DaVinci Instruct. So those are the same things. We don't have a Babbage or an Ada one. But if I switch over to a model, just to give an example of like what another different model is, if I go a long time ago, and let's use Ada. Very, very fast, but very repetitive though, okay? I was a young man who was in love with a young woman, who was a young woman, who was a young woman, who was a young woman. So we can, Ada was able to, generate some response there, but it wasn't as eloquent, okay, as DaVinci was. But Ada can do a lot of functions. Ada can do really good things like classification stuff. So this is, again, we're seeing how much faster they are, but the story you're getting there is a lot more repetitive than something DaVinci would do. DaVinci is going to be much more nuanced. So that's when you see the different engines, their capabilities. DaVinci is great at more nuanced stuff. The other ones are better at being faster, and sometimes they're really good at doing things like classification. But again, the thing to think about is different capabilities, different things. If it's a simpler task, use a smaller engine. More complicated, then use a bigger one. The instruct ones, DaVinci Instruct and Curie Instruct, can be super useful to perform a task. Probably the thing to start with. I wanted to show you how to do prompt design first, but now that you understand a bit about that, when you're trying to create tasks, I would just start on the instruct and say, do this, and see if it does that. And it might just do it right off the bat, and it's great. So we've got, I guess we can keep going here if we have any more questions. We got 5 minutes left yet, or I don't know if you guys need to get ready to go to your next session, which is what clicking over. But I'm going to try to make myself available in the forum to answer questions. It'll be sporadic availability. If you have some technical questions, email the contact you have for that. How do we learn more about the underlying architecture of GPT-3? Well, if you go to the OpenAI website, openai.com, you will find that we have there's an entire article and there's some papers that published. We have a blog post that goes into it, which explains a lot more about it. And then there's a paper that was published that will give you some of the more details. And you can check out some of the other stuff, because the underlying principle that made GPT-3 also applies to other stuff. We've just released information about Dolly and Clip. Dolly is a system that's able to generate images from text descriptions. You tell it, hey, I want to see a picture of a bunny rabbit on a motorcycle. It will generate a photo of a bunny rabbit on a motorcycle. Clip is a really efficient system for telling you what's in an image. So you can say, hey, what is this image? And they'll be like, hey, I think it's a bunny on a motorcycle. You're like, you're right. So you can take that same model of doing prediction, because remember, everything in language models, or models in general, gets broken down into tokens. And a token can be a pixel. It can be anything. It can be a cluster of pixels, like an eye or something like that. Or it can be a word. And that's what it is. It's all tokens at the bottom, which a token is just a number sequence. It's like, 5 numbers, and that's kind of the amazing thing when you look at how everything gets broken down to that level, which our brains do too. If you look at the way our neurons function, they have, calcium channels and areas of, proximity to each other, which kind of has sort of a mathematical variation. And that's where kind of the underlying science of deep learning came from, was trying to look at how our brains function. And it's not like just gates that are on or off. It has to do a lot with probabilities and things that are, we call the weights and biases. So fun stuff. So anyhow, check that out. Go to the blog at openai.com, and you'll see that article about GPT-3 and some other interesting things, kind of the history of some of the things we've been talking about. And any other questions, please let me know. Have fun. Play around with it. The thing to think about is that this is really less than a year old, and people are still finding new things. And you can take a look at what other people have done out there. But if you really think deeply about what does it mean to understand text and to be able to do something meaningful with text, the world of possibilities is endless. There are simple applications that become kind of self-evident, but sometimes the really cool things, if you think about where is some place where you've encountered problems with text, we've had people who've worked on applications to take, legal documents and to simplify them. We've talked about people who are using them to take the output logs from servers and to simplify them. You could use this to simplify things like scientific research. You could use this to simplify things like reports of, malfunctioning devices, all sorts of different things. There's a lot of information. Our whole world is about trying to understand things. And GPT-3 is a wonderful model for trying to make sense of that. It's not the end. It's just sort of the start, but it's a very exciting beginning. So thank you, everybody. And I'll try to be around and hope you have fun. Good luck.
Yeah, thank you for being here.